Welcome back to VT e-Shikshana program on computer-aided engineering drawing. We are working on module 3, that is development of surfaces. Now I will take up the topic development of cone surfaces, solid as cone. Now we have a problem to discuss. A cone of 50 mm diameter and height 60 mm has its base on HP. It is cut by a section plane inclined at 45 degree to HP and bisecting the axis. Draw the development of the remaining portion of the solid, or sometimes they will give the portion containing the base or portion containing the apex. Actually here is the base dia. Okay, actually we have to specify here 50 mm base dia. Unlike the cylinder is having throat cross section, it is 50. Now here it's cone. Okay, having base dia 50 mm, height so much. Now you know in solids as well as the laminae, we learned how to get the circular laminae, and in solids how to draw the projection of the top view and front view, etc. Here the same thing I have identified. Assume that I have a circle as the top view when you keep it on the ground, and the front view is actually equilateral, isosceles triangle. In particular case it is equilateral. When it becomes equilateral triangle, when the base side is equal to sides of the isosceles triangle, then that is limiting case of that. Now before going to the actual problem, let me discuss what happens when you cut the one of the generator. Assume that there is a covering on this with a thin sheet metal, and I will cut here and then open it and keep it on the flat surface. Okay, then you will get the development like this, not necessarily 90 degree or whatever. That again, this angle is depends on the height of the solid and also base diameter. Okay, how you decide this angle, I will tell you, that is very important. Okay, theta equal to R by L multiplied by 360. Okay, this is what the requirement. Now suppose that you have the radius of this, say this is the diameter value, say 50. Okay, now the value of height is say 60, according to this 60. Now how to calculate? Suppose that the entire total development is this. This is theta. Okay, this is what the sector you get. This is L, that is generator length, end generator length. That means true length of the generator. All generators are equal length. Now this is the development. The theta value is R by L by 360. R is base radius, where R is base radius and L is length of generator. All generators of same right regular cone. Even we had right regular cylinder where the axis is perpendicular to the base. Now suppose that I want only portion of the cone, particularly a section plane is made parallel to the base, and only this portion I need, this portion. Okay. Now what is the procedure? It's again simple procedure. Let me identify this as L. Okay, total length generator L. Now this is L1. So you can observe this becomes another cone. This is total cone, and if I treat this portion only, this becomes another cone. Okay. Same thing you calculate, theta you calculate, the subtended angle between the two generators to get this overall development of the cone. You need not have to divide here. Here also no division. Only when you have truncation, then only you have to divide and work out. Otherwise, this is simple procedure. Now I will keep this. Assume that I am keeping this sector. This is theta. Whatever you assume that same dimension is available here. This is 50 diameter 50 pi, okay, height is 60. Now calculate theta, you will get some value. Okay, prepare this. Now only one arc you have to draw, that's all. Radial line method. Only one arc you have to draw, that is with L1 equal to radius, let me say V as center, draw an arc. That is L1 equal to radius, draw an arc. Now this is L1, this is L1, this is L. Total length is L. Okay, so this is very easy method. Then dark only the required portion, that is this portion, dark this portion. That's all. The development of complete cone, this is development of, this is called frustum of cone. That will be decided by the value which is available in the question. Suppose they give only this figure, what to do? They will give this, say 25 dia, 50 dia, height is so 40, they give. So you draw this figure. How to draw this figure? 50 dia you draw first. Okay, assume that I don't have the front view with me. Okay, I draw only this figure. Only this figure first, and then draw one more concentric circle, that is of 25, then project. You will get like this. So how you get this? You project these points at a height of 40. That's all. Don't draw this first. At a height of 40, you draw one line and draw two concentric circles with 50 and 25. Then project these end points. You will get the figure. That's all. No question of divisions. It's only projecting this. Now what you do? How to get L? Total generate, imaginary generator you have to create. You extend this one. Only one you extend and join this also. You also join this and check whether you are going to get coinciding point. Otherwise, somewhere here you have wrong procedure or some difference is there. So keep only axis. Prepare this figure by drawing two concentric circles exactly at the end points. You project at the height of 40. You get these 2 points. Join these two. So this is the figure you have to go. You are going to draw. Then extend this on this vertical projector of V, imaginary V. Then wherever it intersect, you name that as V, imaginary point, V dash. Then take this is L and this is L1. Same procedure follow. So this is how you get the development of full cone, complete plateau surface. This is frustum of cone. Now let me work out a problem on the truncated cone. It is given now. Now how to proceed? It's very easy. As per the cylinder only you have to follow. Keep XY and draw the top view with the given value 50 dia and height 60 mm. Same thing you have to do. Now divide this into n equal parts because truncation is there. Name this as 1, 2, 3, 4, 5, 6, 7, 8. Now project it. See that 4 and 6 are coinciding, 2 and 8 are coinciding once you draw the projection. Then draw thin lines for all imaginary generators. This is V dash, 1 dash, 3 dash, 5 dash, 7 dash. In between you have 2, 4, 6 and 8 with all dash. This is V dash. O1 is there, O dash is there. Do not worry, OV. Sorry, O in bracket V is the top point. Fine. Now, whatever the given section plane is bisecting the axis and inclined at 45 degree. Either you can take leaning upwards right if you draw like this, or leaning downwards right. So normally we take like this. Okay, let us try both. Okay, now first let me take the, by default I always prefer to draw like this because whenever you keep the set square it will go like this. Okay, so by default let me take the section plane this way. Assume that the section plane is only cutting or intersecting the generators, not the base point. We will discuss that also in future. Okay. Now, portion retained after taking section is this. Yes, this is the portion to be retained. Target. Now, name points of intersection. It's as usual in case of prisms, pyramids. Whenever you get base edges, longer edges, or imaginary generators which you have taken into account to be considered. This is V dash 1 dash is intersecting at A dash. V dash 2 dash is intersecting at B dash. Like that. C dash, D, E, F, G, H with suffix dash. For example, V3 and V7 are intersecting at C and G respectively. Similarly, V4 and V6 are intersecting at D and F respectively. The extreme end generator is V dash 5 dash is intersecting at E dash, like that. Now, so again here it is circular pattern. You can use array. Even in the cylinder you can use rectangular pattern. That also you can do. So we will discuss that once I come back with the cylinder. Now, as I told you earlier, assume that I have a sufficient space horizontally. I can draw the inclined line around 30 to 40 degrees, even less as per your availability of space in your place. Then draw an arc. What is the value? This is L. True length of generator, because V1 and V5 are parallel to XY. Definitely V dash 1 dash and V dash 5 dash are true lengths. Okay. None other than these two are true lengths because they all are inclined to both the planes. Say for example, V2 is inclined to XY. Again V dash 2 dash are again inclined to XY. So it's inclined to both the planes. Only V1, V5 are true lengths. Definitely V dash 1 dash, V dash 5 dash are true lengths. You can take that. Then L equal to radius, draw an arc. Then you can use the circular pattern. In that case, we usually keep for laminate and also to solids base of the cone 360 degree. Here, whatever the value you calculate, theta equal to R by L by multiplied by 360, whatever you calculate, that value you should keep. For example, 138 degrees. You keep 138 degrees. And how many divisions? 8 you have to make, but you add 1 because number of lines it counts. So, 9 you enter, that I will show you on computer. Here manually what you do is you approximately calculate the value divided by 12 and take it, or how to divide the given angle into number of equal parts. Say for example this, I have to divide this into 4. How to do it? Take this arc length, more than arc length, draw 2 arcs. 2 divisions you have made. Again take this arc length, more than half of this, draw 2 arcs. Then take the same distance and mark here. Isn't it? Again do that. Again you have to make this into 2. Again take more than this and draw. So you will get 1/8 here. You mark here. Mark here. Say you got 1, 2, 3, 4, 5, 6, 7, 8. Like that. So yeah, this I have to make it. So 8 divisions you get. So by arc method you can do. Now assume that I have used any of these methods manually, and in computer I will show you how exactly I do. Here you draw this. Then assume that I am making 8 divisions with any specific method of your interest. This is 1, 2, 3, 4, 5, 6, 7, 8, 1. Assume that I have made equal divisions. There is some small changes is there. Please bear with me because okay. Now V2, V dash to A dash, I can take directly because it is true length. This is A, fine. But Other than A and E, you are not getting true length. E also I can mark. Draw arc. E. Small size, capital only you mark for entity. Then here 2 and 8 are having same value and DF are having CN. But what is true length? These are not possessing true lengths except these two because they are a true lengths. You project all these points onto true length line, including E you can make it because you will get sequence. In sequence you get. What you do is you take first line, draw arc, second line, draw one more arc covering 2 and 8. Like that you do. So in that case you will get this way. Okay. Or simply draw arcs only. First arc, second arc, third arc to cover the corresponding generators. See for example here after 1 you have to cover V2 and V8. Yes. Till that point you draw arc. Again next point 3 and 7. Draw one more arc by taking this 3 and 7. You can mark here E1 dash, D1 dash, etc. Or you can take in sequence and draw arc. Now this is point B, this is C, this one is D, this is E, this is F, F, G, H, G, H. Now you will get this pattern till A. So many times I have seen people have ended with 8, assuming that I have completed the development. No, it should be one more. That is because of this joint. Now, after this, you dark the boundary. So this is the development of the portion containing the base. Suppose that they ask you to draw the development of the portion containing the apex. What you do? Instead of this pattern is common. You dark the upper side, that is containing V. Now, I will change this red color, portion containing the apex. Red color is portion containing the apex, green color is portion containing the base. Either this or this you will get. Normally by default you have to do this job. Nothing is asked, simply they say remaining solid, only this one. So this is how you can draw the development of the cone, and also if there is any changes then you have to take care. Suppose that instead of this leaning downward left, if they give leaning downward right, then what will be the answer? Now I will use this figure and explain. So assume that I have the same question. Here nothing is given. I have given simply section plane. I have chosen this type 1. This is type 2. Alternate solutions are there. Instead of this leaning downward left, I take leaning downward right. So this is the section plane. Now divide this into unequal parts. 1, 2, 3, 4, 5, 6, 7, 8. So project this up. Assume that I have made this only dot. All are light lines. Okay. Fine. Now naming the points. This is V. This is VO. Now 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6, 7, 8. This is V dash, O dash. Now name the points of intersection. This is A dash, B dash, C dash, D dash, E dash, F, G, H. It is moving up in that case. Here it is moving down because I have taken downwards right. So what will be the pattern you get? Now let me take this. Assume that I have used the procedure for drawing the development, complete overall development. Theta I have calculated and I got theta value. After that I divided this into 8 equal parts. I can use circular pattern and do it. Now this is 1, 2, 3, 4, 5, 6, 7, 8, 1. And this is theta value, theta equal to something. Okay, then you have to calculate. Then what exactly you have to do? Here also V dash A dash and V dash E dash gets you true length, none other than these two. For that you have to draw horizontal lines including A, you better draw, so that in sequence you get 5 radii, 1, 2, 3, 6, 4, 5. You draw lines. So here A is going to cover 1, 1, okay, from the starting point. This is 2, 2 for 2 and 8, then 3 for 3 and 7, then one more point here, then last point is this only. Suppose that it passes through the right extreme base corner, base point, like this here, this only is the point. Now join these points. Before that, let me name these points. This is A, B, small size capitals only, right? This is D, this one is E, here is this point, okay, this point. Then this is, we take it a bit closer so that you will get idea. Okay. This is E, yes, this is E, this one is D, F, G, H, A. Now, what exactly the requirement? Requirement is the pattern. So very interesting. It's you get pattern like a necklace. Okay, fine. Starting from A, this one, then dark the portion which is remaining of taking section. So this is the pattern you get with the section plane leaning downwards right. This is section plane leaning downwards left. So either of these two section planes you can consider for this problem unless they specify. Okay, sometimes they give figure itself. In that case you have to follow that. Otherwise either this way or this way. But I will tell you, with this problem only you will get this pattern. How? Instead of starting from 1, if you start from 5, definitely you will get this pattern, because the 5 is having the point nearest to the apex. Yes, we have. So you will get, as in cylinder, I have explained this with models. This pattern also you get when you start the point, starting point as 5, V5 as the point. In this case also you get that pattern if you start from again 5. So take care of this. You try to explore by taking the various types of section planes and get idea. Then I will show the same on computer. Let me work some problems on cone and cylinders. Already we have worked out cylinders. Now the problem of cones with development as the topic. Draw the development of a cone of 50 mm base diameter and height 60 mm. That's all. This is a simple question, but just for the basics we have to cover. What exactly the top view when it is resting on the base? Draw the development of a cone of 50 mm base diameter and height. It's by default, let us assume that the base is on the ground and the axis is naturally vertical. Okay, and we have to draw the top view as the circle, that is base circle equal to 50 mm diameter and the height equal to 60. In that case, for the procedure we have to measure the end generator length, that is true length of the generators. It consists of infinite number of generators. Assuming that we have 12 or 8 divisions, and then we are going to name it and do it if the truncated solids are there. Otherwise, just you have to take the generator, one end generator, and measure how much it is. Next, what exactly this line? This line is actually the axis. So you have to change this to axis. Normally, while drawing the projection, we will keep the thin line, and let us convert that into the axis representation. Yes, this is how you represent the axis. Now, how to create the development? Development as already as I explained in the manual drawing. Now you will get like this. This is the development. This is, there are two parameters here. One is angle substituted between these two generators and the true length. So true length equal to radius, draw an arc first. Okay. Then try to divide this 138 degrees or whatever you get. See that theta can be calculated like theta equal to r by L, whole thing is multiplied by 360. In this case, it is 25 is the base radius and the length is 65. If you calculate, you will get 138.46. You can take for all particular purposes 138 or simply 138.46 only you can enter. In circular array, we are going to divide this. How to divide this in circular array? I will tell you. Now, let me take up this and divide. Now, take this L, that is small l, 65, selected here, and then go to this circular array, circular pattern. Now enter angle. How many divisions you want? 8 divisions. In that case, you have to keep 9 count, so that you will get 8 divisions. Now here it is telling click for the center point of the circular array. Yes, this is vertex V. Let me click. Then how many? 9. If it is different, you convert that into 9. Change it to 9. Next, 138.46 only you keep it. Yes, you, if there is any other value, 360 or 180 or whatever, you change it to 138.46. But we got yes. That's all. Next, just finish. You say finish. That's all. You get the automatically. You get no magic here. It is only the software capability. Okay. So whatever the value you have subtended angle, you can divide that into the number of divisions. Okay, automatically. Same way, you can use rectangular array for what? The cylinder. Okay, I told you with offset method, you can also use this rectangular pattern. Here it is circular pattern. You can use the rectangular pattern. I will tell you how to use that. Okay, now before that, let me complete this procedure. If you have complete cone, lateral surface, slant surface, that is curved surface, you can do this way. But for this, you need not have to divide this into n equal parts. If there is any truncation, then only you have to do it. Okay, this is only for procedure purpose I told you. So here is only the total development is this. L as radius, draw an arc, very big arc. Then start with a generator, say V, assume that this is A, VA, and end up with VA only. Total, this one is called development of cone. Now this one is necessary only for the truncated solids, just for procedure I told you. Suppose that you have the what is called the frustum of cone. They will give the total cone and then distance from the top end, that is apex 25 mm. How to draw this? It's very easy. You take total length, that is generator length, and draw an arc. And also after calculating this, you try to fix this. How to fix this? I will tell you. Here only I will tell you. This one I delete. Okay, now how to fix this? It's very easy job. Take this line 65 mm, 65. Better use keyboard only, the computer, then click. Then check again whether you got the correct value. 65, yes, 65. Now, this is reference. You take arc by center point, draw an arc. Better go with this direction only, in this, don't go above. Then you get a draw big arc. Then from this point, draw one more line. Not a specific value, you can take one more line. little extra. Now you fix this to the value which is available here. Okay, that is 138.46. You will get 138 only. Okay, 138.46. Yes, since it is computer reducible, yes. See, you will get 138 only. It will round off to the single degree. Okay, now trim this. Trim these two. Then dark all the portion. Okay. Dark all this. Suppose that you get complete development. That's what I got it here. Take L1 that is available here with the particular height which is for the removed to be portion to be removed 27.08 and draw an arc. That's all you have to do. So in that case you will get the development for frustum of core. Here also you need not have to divide this into unequal parts. You will get like, suppose that you get a problem of this type, they don't give total height of the cone, they will only give only frustum of cone height and this diameters. Say this is 50 and this is 20. So according to this is 50, this is some value. Now what you do is, you try to draw this figure, two concentric circles, and get the front view. Project this inner circle ends of diameter at a height of 25 or 35, whatever the height given. Then project this axis and then project this like this. You will get apex. Then you measure the length of generator, true length of generator. Then this one. Then try to process in this method, whatever I have done now. Okay. So this is about the cone and frustum of cone. Next, truncated cone, how to do it. Now let me take a problem, whatever I worked out manually. A cone of 50 mm diameter and 60 mm height as its base on HP. It is kept by a section plane inclined at 45 degree to HP and bisecting the axis of the solid. Draw the development of the lateral surface of the remaining solid. What exactly you have to do? You have to divide this into n equal parts. So how to do it? Okay, I explained this. Okay, how to divide that into n, because you are taking this into consideration. You can divide by circular pattern. Okay, like this. Okay. Now, suppose that you have the cylinder. The last session I did it. If you want to use like the circular pattern for the cone, if you want to use the rectangular pattern for cylinder also, you can definitely use it. See, here you prepare the starting generator, that is AA1, say AA1. Then draw two parallels, little big size, so lengthy one. Then so that the 8 segments have to accommodate. Now what you do is, take this circular pattern, sorry, rectangular pattern, select this line, yeah, sorry, this is no, that's all. Then select, then finish. That's all. You see, nothing has come, only one single row. You have to say X count, Y count 1, okay, single. So this is how you get. You trim these two and process. So this is as good as going for offset in the regular prisms and what is called the any time you want to extend this for number of times, you can use this. Okay, but you must add 1 plus. That's all. Next, let me come to the actual problem of this cone. First you identify these and then prepare this. Then say A, B, C, D, E, F, okay, G, H, again A, okay, that you do. Here you have to name it. Then measure the distances after taking the section plane. Section plane is actually bisecting the axis inclined at 45 degree. Okay, now this VA is intersecting at 1, VB at 2, 3 between VC. Similarly, 4 and 5 between VD and VE. Similarly, 6 and 7, 8. So, you have to take these distances and mark here on this true length, because why we are taking to one side, either to the left side or the, because this is going to give true length for us. Now, we start from the always. Here we have taken from the base. Always you better take from apex. Okay. So the distances you take and draw arcs there. Okay. Now you will get this pattern. So how to get this pattern? We will check. Now I will take this and let you know how to do it. Okay, let me take this out. Now let me start working using curve. Okay. Assume that I have all our light lines. I am going over only this pattern. Now take this first end point, then another end point, yes, end point. Assuming that all I have recorded as per the distances measured. Yeah, here you get like this. Now better try to know, suppose that somebody wants, you don't want to start from A. By default, normally we start from A. Somebody wants to start from E. Yes, you can do it. E, F, G, H, I, J. Same pattern, same procedure, everything. Instead of A, B, C, D, you start from this end. This is P end, this is Q end. Say, I am starting from P end. So, Q end. Now, Q end started with E, F, G, H, like this. Now, same values you have to take. Say at E, you have this 5, yes. You measure the true length from the base end, that is E to that, like that. Or you can take distances from the apex and draw radius. That's what I did it. Manually I am doing it. Even otherwise you can take distances from there and draw arcs. Then trim, you can trim afterwards. See, after getting this, you can trim. I will trim whatever the available things. See, I can trim unwanted this one. Here, like this. I can retain only the inside. Like this I can retain, trim. If you don't want, you can draw only to the specific thing. Here also, this side also you can take out. So whatever the best you can do. See, you have synergy in this particular softwares using graphics, you can do it. Now you get the profile like a necklace. Okay, so this is what I worked out. I did it. Now this is the curve. Both are correct. If you close it about A, V, F, V, and if you fold it and make it one, fold it, you will definitely get the same thing. Either both are correct. This is also correct and that is also correct. Okay. Now, preferably you start from A. Now, the thing is, here the working of the pattern is very important. Suppose that the same pattern is leaning downwards right. Suppose you start there from A. So this problem you are getting like this. If you start like this, leaning downwards right, definitely you get the other one. Okay. So this one only you get, this pattern only you get, because this is the highest point, this is the lowest point. So you will get same problem, same pattern you get. So A, B, C, D, both patterns are correct. So assume that you are working in a classroom, you just observe your friends are doing the same thing, but they are getting different pattern. Don't think that yours is mistake, but you are done in a particular way, taking A as reference or E as reference. If you take E as reference, be careful. If it is a single development piece, a single piece of development, then you must be very careful when it cuts the base. Then only you must be very careful. Otherwise, it's clear. Now, let me conclude what exactly we have done. We have taken a total cone lateral surface, that is curved surface. Then we made this as the development. No divisions necessary here. take one line, that is starting line as the generator, true length of generator, and then draw an arc, then use circular pattern and complete. Okay. So this is how we can complete. Suppose that if the uh, portion of the cone is required, particularly frustrum of cone, then you make the total cone by extending this frustrum of cone to reach the imaginary vertex. Then take this distance, draw an arc, make it dark. So rest of the place is available. So only this portion is to be removed. So all figures of development of cone must be associated with this calculation. Otherwise, there is no value for this, because without this you cannot do. Simply, if you say 138, somewhere you calculate and do it, that is not correct. You must always keep by the side whatever the calculations you have done. Suppose that you will get the exclusively frustrum of cone dimensions, then you can extend and get imaginary V, then take the total development and then take out. That's what I explained. Then if the truncation is there, 45 degree to HP and bisecting the axis for a section plane, either you can take leaning downwards right or leaning downwards left. So normally we take leaning downwards left. That's what we did it here. Okay, in this case, leaning downwards left. Then better you take distances from the apex always. Okay, so that you can draw arcs specifically from the. Otherwise, you have to search for whether it's E or B, etc. This is also okay. You can do it, but normally you take from the apex. So this is the way you get. If this is the pattern, okay, leaning left downwards, this is the lowest point, this is the highest point. So this is the highest point at E, lowest point at A. So then pattern will come. Suppose that if it is leaning downwards right, then this becomes highest point. That means at A you will have this highest point, and then you get the pattern like necklace. Okay, this is the highest point, this is the lowest point, you will get like this. So that is to be taken care like this. Then rest of the boundary are dark, and these are okay, very light. Okay. Next, this is how you solve the problems on cone, and then we will take up some typical problems in this module and work out.